Hello and welcome to a new video. Today we discuss the polymer material selection for a smartphone front bezel. Okay, let us get started. So before we go into the details of the selection example, I would like to introduce briefly myself. Who is Herwig? So my name is Herwig. I'm already over 10 years active in the plastics industry. Worked for major material suppliers and also startups. Have built up know-how in the area of engineering and high-performance polymers, especially in the field of material selection, and also metal replacement for the industries of automotive, consumer, healthcare industry. And I offer also online and offline polymer consulting in the area of material selection, troubleshooting, part failure analysis. To my education, I started polymer engineering as a bachelor and master, and did also my PhD in the area of polymer injection molding. I have two major platforms. It's findoutaboutplastics.com since 2014. It's my blog platform, and also polymermaterialselection.com, where you can find additional information on how to structurally select plastics, also online tools, and so on. And then there's also herwigjuster.com. It's my name domain. Okay, let us take a step back before we start with the example, and I'll give you some information on polymer material selection in general. Polymer material selection. So why it is so important? Because proper selection can take you to the moon, as here shown in the example, the Apollo 11 mission. And the crew themselves was equipped with the latest technology. And when you look at their helmet, there were two major polymers responsible for protecting the head. So on the one hand, we had polycarbonate as a protective helmet visor inside, and also on the outside polysulfone as a sun protection helmet visor. So here it was particularly important. Also around this time in 1969, there were not yet all the polymers and compounds available like in 2024. And so here the engineers were really careful to select the optimal polymer for those two applications. And as I said before, proper material selection can take you to the moon, or you are not even able to lift. And when we think back to the Challenger disaster in the year 1986, where the wrong rubber was selected for a particular O-ring for sealing, which allowed then in certain temperatures no proper sealing, led to this disaster. So it's really important to prevent also part failure at a later stage by selecting the optimal material. And for making a successful plastic part, the material selection is one of 5 critical parts. And this is shown here in this pentagram, what is also called the polymer product pentagram. So we start with a good part design, so optimized also for plastics. Then we have the material selection, followed by a proper mold design and also the construction of it. Then we have the molding machine, selecting the optimal molding machine, and then the molding process. So also there, based on which material you use the right temperatures and the right molding. And then we can close the loop again towards the part design. So this is one of the material selection, is one of these 5 critical factors for making a successful plastic part. Question is now, what do we need for a successful plastic material selection? So we need to have first the understanding of the polymer material characteristics themselves. So are we having an amorphous polymer, a semi-crystalline thermoplastic? Do we have a thermoset? Do we have rubber? So this is the first. Second, we need to note the specific material limitation and failure modes. And also, thirdly, the consideration of all the application requirements, mechanical, thermal, environmental, and so on, chemical. And also the production factors we need to think of when you think back to the pentagram. Which processing method do I choose to have also to manufacture the plastic part in an economic way? And also, I mentioned already economics, so also keep in mind material costs versus the density, for example, so thinking in volumes and not in kilograms to fill the parts, cycle times, and the overall part prices. Everything needs there to be considered. So to conclude this, designing with the material in mind will lead to a successful material selection. And now we have a look how we can do that for the smartphone front bezel. Great. Let us now go to our example, the smartphone front bezel. You can see it here, a picture of it. So it's really a thin frame, and it needs to take up some lenses and antennas. We will discuss now the requirements in detail. And to make it systematic, we will use the so-called polymer selection funnel method. It's a 4-step process. And the base step is an information gathering phase. So we get all kind of information on the part, on the application requirements, already some material ideas and so on. But the first major step is the material selection factors. So there we turn the application requirements into material property data. This is the first phase. Then we decide between thermoplastic or thermoset. And if you go with a thermoplastic, is it amorphous or a semi-crystalline or both options? The third is then the core of the whole selection funnel, is the selection discussion with worksheet, where we systematically rank all the requirements with the pre-selected material. And the outcome of this third funnel step is then 1-2 material options. And with those, we can start testing and start discussing with material suppliers, vendors, and make then the final decision. Important is also that for each funnel step, certain tools can be used which support you in your decision making. For example, in the first funnel step, material selection factors, we can work with material and application requirement checklists and also the requirement worksheet. I will show you then. In the second funnel step, decision thermoplastic or thermoset, we have plastic material databases such as Campus, Omnexus, MedWeb, Granta Selector, and also dashboards. In the third funnel step, there where we have the selection discussion, we can use the qualitative matrix analysis together with the polymer material selector. And in the last step, where it's about rapid prototyping, also we can use virtual prototyping, like using filling simulations or finite element analysis for mechanic assessment, and so on. So these are just examples also of tools, but it's a guideline for each of the funnel steps that you know what you can count on. Okay, now let us start with the first funnel step, the material selection factor. Here again, our example of the front bezel, LCD front bezel. And now the first step is the collecting of the requirements of this type of application. Okay, and in this first phase, it's important to understand the requirements of the application as good as possible. And for that, I created what I call the 6 WHATs, which can support you, guide you by finding the answers for your requirements of the application. Like the first what is the service environment of your part? what are the regulatory requirements, what type of loads you expect, what other things like friction and wear, what will be the processing method, and additional fabrication methods, post-processing topics, what is the economic and commercial expectation and considerations. And there are many more questions, and I have a link to even more questions in the blog post of this example. I will link this also below. On the right side here, you can see now the requirements worksheet filled out. So here we collected all the requirements for this type of application, and we turned this requirement into a material property with qualitative and quantitative values, and also if it is a must-have or nice-to-have, and also ranked it already a bit, that we know, okay, what is the most important and what is not as important in this stage. Once this step is done, we move on to the funnel step 2, decision between thermoplastic and thermoset. Okay, now we have a clear understanding of the requirements. We can start looking into databases and also at material suppliers to find suitable material candidates. So first, we need to decide between, do we want to go the road of thermoplastic or thermoset? When you look at this application, we need good impact performance at low and higher temperature. As well, we have millions of parts are needed to be produced. So here, thermosets are the way to move forward. The decision between amorphous and semi-crystalline. Here, both options are available to be considered. So our case, I proposed a polycarbonate copolymer as an amorphous solution, and semi-crystalline we have polyamide 610, a blend of PPT and SEN, and a high performance polyamide. Okay, let's move on to the third step of the funnel, the selection discussion with the worksheet. Here you can see already the results of this, what are called the qualitative matrix analysis. And what we do here on the top, we insert our material requirements and we rank them again with the importance from 1 to 5. And then on the left, we add the pre-selected materials, what I have shown before in the previous funnel step. And then we go through each of the requirements with each material and look how good it can fulfill this requirement. And again, we rank it from 1 to 5. And then all these values get multiplied together and added up. And then we get a final number, which allows us then to make a ranking of the solutions. I created also an online tool where you can plug all these requirements in and the materials and then just fill in the numbers. However, I also have an Excel sheet which I can send you. You just need to get in contact with me for this. And for example, let's take the first row of the PC copolymer. So the unnotched isot impact, it fulfills with the level of 3. And it has an importance of 3. So we multiply 3 by 3, it's 9. Plus, then the next row is the tensile stress. So it's 3 multiplied by 4 and added up. So we have here 12 plus 9 and so on. And so we walk through the whole and then we get this number. Okay, now with the ranking of the materials of the pre-selected, let us move on to the final step where we need to first select 1 or 2 candidates and test them, make prototyping, make virtual prototyping, filling simulations, and then make a decision to select and get in touch with vendors. Okay, regarding the tests, there are some specific tests for these bezels. For example, there's the antenna performance test. You need to pass certain amount of signal. There is the falling and rolling test. There is the anti-stain test. So we don't, when we put this in our trousers and so on, we don't want that the materials leave stain on the clothes. And after passing all these tests with the material, we can also making some filling simulation, some virtual investigations that we can make the final decision. And in our case, the decision was made for the premium consumer segment of smartphones to go along with the polyamide 610 with 45 weight% glass fiber and a polycarbonate copolymer with 20% glass fibers. And if the surface aspects are not the most important criteria, so the other two materials, such as the high performance polyamide and the PPT SEN, can be considered too. So these are how the final decision in this case looks like. Okay, we made it through the polymer selection funnel, and now it's time to wrap up what we learned today. So firstly, the plastic part failure is connected also to human errors, misunderstandings, and we must accept this fact. However, we have it in our hands to turn it better. And we also must accept that also engineers and designers, they have only limited time also for certain steps in the whole part design phase, and therefore the know-how transfer, the knowledge need to be really efficient. Another important point is the fundamental understanding between the nature of polymeric materials compared to traditional engineering materials such as metals. So there are quite some differences, and with these differences in mind, selection and the part success will be much more likely. Also, we discussed the product polymer pentagram. So the optimal outcome you will get if you consider all 5 steps. So not only material selection, but also part design, the mold design, the machine selection, and also the processing of the material itself then to the final part. And what we discussed with the polymer selection funnel, a systematic approach in your material selection process will help you to really not fall in all these traps and keep also a good overview of the of this. Okay, now what to do next? Subscribe to the channel if not yet done. If you like this video, leave me a like. It will help the algorithm. Then check out below the blog post on this whole example with all the links I have included there. And I would like to thank you for watching today, to be part of this selection example, and see you in the next video. Bye.